Hello, everybody. Thank you for the introduction, Tulika. Glad to see some of the people who were at the booth earlier, so I'm glad to have you all here. My name is Andreas. I'm going to be talking about Spark Declarative Pipelines, how to master the shift from imperative scripts to declarative flows, and that's in Spark 4.1. So what is Spark Declarative Pipelines? It is new. Who has heard of it before? Nobody else. Okay. That's going to change. So what can you do in declarative pipelines? You can define data pipelines. You can also validate them without running them, but then you can actually execute them. It's built on top of existing Spark components, such as Spark SQL, PySpark, structured streaming. It has first-class support for Python and for SQL, and you can actually mix and match Python and SQL in a single pipeline. And it has support for both batch and for streaming. And we're going to see the details very soon. So what are we going to do? We're going to first talk about, in general, why is it good to use declarative frameworks? Then we're going to look at SDP specifically. What are the elements of a pipeline, of a declarative pipeline? And finally, we're going to look at the actual structure of a project in SDP. So the shift from imperative to declarative. Who here in the room is already using declarative frameworks? Yeah, you know a few? Okay, I can name some. For example, Kubernetes, Terraform, Airflow, right? These are all declarative frameworks where instead of writing code, you write a configuration or a specification, and the framework makes sure that the system fulfills that specification, right? So declarative is actually not new, right? It's a known concept. How about Spark? So in Spark actually is a declarative framework. If you use Spark SQL or you use data frames in Spark, they are already declarative. You specify what you want. Spark takes that, translates it into a physical plan, executes that physical plan, and so it's really declarative already. But what is not declarative in Spark today, or until today, is the orchestration of multiple queries and multiple data sets, right? That is still something where you had to write a Python script or a SQL script and figure it out yourself, right? And so that is changing with Spark Declarative Pipelines. It extends this declarative model to the entire pipeline, right? So where in the imperative style, you had to write your code manually, you had to take care of things like retries, like parallelism, like ordering, sequencing, dependencies, schema evolution, all these things had to be coded manually, right? Whereas in the declarative world, all you do is you describe what data you want in what data sets, and the framework makes sure that that data materializes there, right? So let's look at an example. So this is a very simple pipeline, right? Let's say you have customer data, you have order data, you want to join them together to enrich your orders with the customer information. Right? If you look at this simple pipeline, you will quickly notice that the first two queries here, they actually don't depend on each other. So they could actually run in parallel. Right? But how do you do that? How do you run these two in parallel? If you write this in SQL, you can't do it at all, right? Because SQL scripts just run in sequence. So you'd have to write it in Python, right? And you'll end up with something like this. Right? You'll have like multi-threading code mixed into the business logic of your pipeline, right? And why is that bad? Well, A, it's error-prone, right? It's very easy to make mistakes. Even though we all grew up in the era of concurrent programming, concurrency is not trivial, and especially when your pipeline changes. Let's say you add another data set to it, right? Now you have to update your threading code, right? It's just distracting. And also not everybody has these skills, right? And it distracts from the business logic in your pipeline. So we want to move away from that paradigm, and we want to do something better. So in SDP, all you do is, you can use SQL, and you define your data sets using the queries that dictate what data should be in them. And you don't even have to specify them in the right order, right? Like, so here, for example, I'm defining this rich orders first. It doesn't matter. The framework will figure out what are the data dependencies and in what order does the pipeline have to execute. Right? So that's a big advantage. And you can really focus on the business logic. Right? So in a declarative paradigm, the developer only defines what tables should exist and what are the queries that define them. The framework, SDP, automatically handles things like checkpointing, the order of execution, data dependencies, error handling and retries, running things in parallel, and also item potency, right? This is a big deal. If you hand code this, and let's say you have a query that appends data, and your pipeline fails halfway, now you run it again, it's going to append that same data again, right? So managing the state and making sure it's item potent is a burden. And a declarative framework takes that burden away from you. And what you end up with is cleaner code and automatic orchestration. And it's also easier to test because you don't have to test the orchestration part. You only have to test your business logic. Does that make sense? Oh, I see some nods. Good. Cool. Right, and so we say this is actually a shift left to, basically allowing you to validate your pipeline before you actually run it. And this is actually a big advantage, right? So in an imperative script, the script will execute, and let's say you have a mistake, a syntax error or a typo, you misspell some column, and that's at the very end of your script. Then maybe the script has already run for hours. Now it finds an error, right? Now you've wasted hours of compute time. In a declarative framework, SDP actually, it can analyze the entire pipeline before it runs any code, right? So what it does is it builds a data flow graph from the definitions that you provided, and then it validates the entire data flow graph first. And it will check, do all the schemas match? And if the schemas don't match, can I do a schema evolution? For example, if there's a new column that's showing up in one of the sources, you can just evolve the schema of the target by adding that column. So all these things happen before any code runs. Then it executes the pipeline, and now you pretty much already know that this pipeline is not going to fail. Right? Of course, there's always failure scenarios, but the chance is much lower. Your business logic has been validated. What else does SDP handle for you? It also handles state. Who is using structured streaming here? Okay, so you know in Spark when you use structured streaming you have to provide a checkpoint location, right? And you have to manage these checkpoints. In SDP that is done for you. SDP will find a storage location, it'll have the checkpoints there, and you don't need to worry about it. And as we saw earlier, SDP will also do parallelization for you. Because it knows the entire data flow graph, it can analyze the dependencies, it can find out how much can run in parallel, and will then automatically do it for you. Pretty cool, huh? All right. So now that we're familiar with the concept of declarative pipelines, let's look at what concretely are the elements of a declarative pipeline, right? What do you think could be there? Datasets, queries, maybe views. So let's look at this. So there are actually 4 types of datasets. One of them is called a streaming table. Another one is called a materialized view. They look at first glance, they look very similar, but there are some very crucial differences, and we'll see what that is. Both of these persist data. So they process data and they write their output to actual tables. Whereas temporary views and views are virtual, right? They only define a logical plan, And when a downstream data set reads from that view, then that logical plan, that query that defines the view, is simply inlined into the query that defines that downstream data set. Right, and so they are really, I mean, everybody here is probably familiar with the concept of views, but they help you structure your code, right? And you can, for example, take common sub-expressions and put them in a view so that you can reuse them and not have to write them multiple times. All right, so let's look at streaming tables. Streaming tables are computed using structured streaming. I think the mic goes on and off. It's kind of weird. Is that me or is it okay, I guess as long as I look, if everybody can hear me, I'll just speak loud.
Do you want like a microphone?
I guess I can speak loud enough.
Yes. You got this.
All right, then let's turn this one up. All right, so where were we? Yeah, so streaming tables are computed using structured streaming. And they are persisted as tables, and the checkpoints are also persisted in a sort of hidden location managed by the framework for you. What is the use case? The use case for streaming tables is typically the bronze layer of your pipeline. So this is where you ingest the original data into the pipeline. Very often you will ingest that from a place that doesn't retain the data very long. Let's say you read from a Kafka that has a retention of 1 week. It's gone out again. I don't have good microphone karma, I think. Can I just talk without the microphone? Can everyone hear me if I speak? Okay.
You can remove the other mic.
Okay. So the bronze table, you want to persist that data every time without that convention. So that is the main use case of streaming tables. There are others, but this is the main use case.
Both a lab and a handheld started doing the same problem again. It looks like it's a signal or a frequency issue. It's not batteries. But they've now opted to not use microphone anymore because they got tired of the issue. I understand. Frequency setup channeling.
Abstractions for, oh, is it back? Okay, I'm going to lower my voice again. So they are not persisted. The only thing that's persisted is the definition of the view is persisted as metadata, right? So every time you query it, that query is executed again. But the nice thing is you can reuse that within your pipeline, also outside of your pipeline, because it is a permanent view. Whereas temporary views are only visible within your pipeline, right? And so this is where you can have intermediate results that you don't want to expose to the outside. Okay, so these were all the data sets. Is that all that's in the pipeline? Well, there's a little bit more, because not everything is a table, right? Sometimes you want to write to a target that's not a table. Maybe you want to write back to a Kafka. And so for that, we have sinks, right? Sinks, again, they are implemented under the covers as for each batch. So every time you process, for each batch runs, they are persisted in whatever the storage medium of that target is, right? Here in this example, it's Kafka. What you don't get here is item potency guarantees, because we don't know whether your target supports item potency, right? So you need to know that when you use them. And the use case is, yeah, custom targets, right? But it allows you to do pretty much anything that you want to do with your data. Another thing that is not a data set is a flow. And this might be a new concept to many people. A flow is kind of a persisted query, right? And why is this useful? Well, what you can do is you can define a streaming table without giving a query. And then you can define a flow independently that writes to that table. Now, that looks just the same as defining the streaming table with a query. But the key point here is you can have multiple flows for one target table. So for example, let's say you have data in Kafka and in Kinesis. You could define a target table, and then you can have two flows, one reading from Kafka, one reading from Kinesis, and they can both target the same table. Right? So this is kind of a logical separation of the target table and the flows that write to it. Okay, so we've seen the main concepts that exist in pipelines. Now I want to look at what a project in SDP actually looks like. So in SDP, if you want to use it, you use the CLI. And the CLI, it looks very, very similar to Spark Submit. It's actually built on top, it's a wrapper on top of Spark Submit that understands the structure of your pipeline project and passes additional arguments to Spark Submit. Now, what that means is you can run pipelines wherever you can run Spark Submit. Now, what does a project look like? Well, one thing you can do is you can actually use Spark pipelines in it. So this creates a standard sort of scaffolding for you for the structure of your pipeline. Right? What you typically have in the pipeline is you have a YAML file that describes the pipeline. And then you have the source code for all of your data sets and your flows and your sinks. And they don't have to be, but the standard scaffolding puts them under a subfolder called transformations. And they can be in Python, they can be in SQL. You can mix and match and distribute them across as many files as you want. And then typically a README, which documents what this pipeline does. So that's what the structure is like. And now let's look at this pipeline YAML file, right? Because that really describes what your pipeline is supposed to do. Really, the only two fields that are required here are the name and the definitions. The name, obviously, you want to give it a name. The definitions is the list of files or the set of files that belong to this pipeline, right? And so here you can specify just file names, or you can actually use glob syntax, wildcard syntax to match multiple files. So in our example, we just include all the Python files and all the SQL files under transformations. Optionally, you can specify a catalog. If you don't specify one, it's just going to be the default catalog. Same thing for a database or schema. If you don't specify one, it goes to your default database. And if you want, you can specify configurations. You don't have to, but in some cases it could be useful, right? So you can, if you want to, you can influence, for example, the shuffle partitions for Spark. This is for the advanced user if you really want to fine-tune the pipeline. The principle in many declarative pipelines is, declarative frameworks is that for the novice user, you don't need any configuration. But the advanced user has ways to specify some configurations, right? And that's what you get here through configuration. All right, so this is the pipeline YAML. And now, how do you run the pipeline? Well, we talked earlier about it, right? There's a way to validate the pipeline before you even run it, right? And you can, I mean, the SDP framework always does that before it executes a pipeline. But you can actually do it explicitly yourself. Spark Pipelines has a command called dry run, right? And so when you do dry run, it does only the first 2 steps there. It reads all your files, executes them to get the definitions, and builds the data flow graph. And then it validates the data flow graph and all the schemas in it. And then it stops. Right? So that way you can test whether your data flow graph is well formed without actually running the code. Right? But then when you run it, yeah, you just don't give the -- dry run argument. You can also give it additional arguments. For example, here you can say, what's the Spark master, right? Anything that you can pass to Spark submit. Okay, so what is the typical workflow of a developer here? Well, you write your pipeline code, and then you run a dry run. Right? You validate it, and you check, is everything okay? And if it's not okay, are there actually errors? Okay, I'm going to fix my errors, fix my code, and I'll go back to validate again. Eventually, I'm going to be happy, and I'll say, this looks good, right? Let's run it, and then I run it for real. This saves a lot of time, right? Because in those iterative cycles of like testing, validating, and fixing your code, right? This is what we often go through. We don't actually have to execute the code, right? It's much faster. Right? So this way we catch bugs very early in our cycle. Now, I want to talk about a couple more arguments that we can provide. So by default, you just say Spark pipelines run, right? And that runs the entire pipeline. For streaming tables, that means it processes only new data, just like structured streaming does. For materialized views, it means it recomputes the materialized view. Checkpoints are managed for you. And yeah, existing data is preserved. Now, sometimes, especially during development, you may only want to run a subset of the pipeline because you're developing and your first 5 data sets are ready and you're working on the 6th one, right? And now you really only need to test that one, right? And so you can give a refresh selection, and that refresh selection says which data sets should actually be executed here or which flows. And then it only runs that subset. Now, earlier we talked about the fact that streaming tables have state, right? And what that means, if you do something to the schema, for example, then older records in the table don't reflect the full schema, right? They may have some null columns in them. But what happens if you make a change to the schema, or you found a bug in your business logic that, I don't know, computed dates in the wrong way, and you actually want to reset it to empty and recompute it from scratch, right? There's a way to do that, and that's called full refresh, right? So when you do a full refresh, again, you have 2 ways to do that. You can do a full refresh all, and it basically deletes all states in the pipeline and starts over fresh. But you also have a way to specify a full refresh selection, which does this only for the data sets that you specified. Right? So these are pretty much the 4 ways that you can run declarative pipelines. So that almost concludes my talk, but because we're here also to talk about Spark, SDP is a new feature in Spark 4.1, but there are many, many other new features. I really, really recommend you try them out. Spark Connect actually came in Spark 4.0. We have real-time mode for structured streaming. Did anybody see Jerry's talk? No? Yeah, see, a really cool feature. We have enhancements to SQL. We have PySpark UDFs. We have so many improvements. Read the release notes. There's a lot there. And try it out. And because Spark is a very inclusive community, we all want to invite you to join the community. So if you want to, find us on GitHub, find us on spark.apache.org. You will be very welcome there. And that concludes my talk. But we're not done because I do want to get some questions.